Here comes the second part of my working solution to this exam 2. As I mentioned, this year they just reduced the number of questions to 4 extended response questions. There are still 60 marks. So let's have a look at these 60 marks worth short answer questions. Question 1, you have a function like this one. Let me just grab the CAS calculator. And we want to find, let's say, the derivative to find a stationary point with this polynomial. Okay. Then we sketch the graph after we find the stationary points. Notice the scale will be, let's say, -2 to 2, -2 to 2, but here I will set -3 to 3. X value is 1, X scale 2 here, -2 here, but just set a 1 here so we can see a 1-to-1 square grid. And then I just type g of x. So you can see this graph here. Notice you should get the x-intercept 0, 4 over 3, okay? I do have a stationary point here. That is a local maximum. So let me just imitate this graph and draw it nicely. So approximately you should draw a graph like that, okay? Make sure you show some good curvature. Yep, that's pretty much the graph. You need to label the stationary points and the x-intercept. So this one is a stationary point of inflection. This one is another x-intercept. This is your maximum. Gradient table to ascertain G has a stationary point of inflection. We know it's around 0. The gradient is 0. Now, whenever you sub in values or into the gradient function, the x value on the left of 0, you should make sure it's somewhere negative, okay? And you can't just sub, let's say, x equals to 1 point something. Basically, for the other side, you can only select values between 0 and 1. So what I'm going to do, for example, there will be a wide range of answers, but I just pick, let's say, some convenient value, for example, -half, 0, and half. So once I sub them in, like when x equals to -half, the gradient is 9 over 2, which is larger than 0. And when x is half, we have 3 over 2, which is also larger than 0. So the slopes looks like up, flat, up. That's why it's a stationary point of inflection. So moving on, average value of G from 0 to 2. You might want to write your answer like this, or -1.6 is also a correct answer. H be the result after applying a sequence of transformations to G such that H has a stationary point of inflection at 1, 0 and a local maxima at minus 1, 1. Write down a possible sequence of 3 transformations to map from G to H. So if you look at the graph over there, if you want the point of inflection to be 1, 0 and a local maximum at minus 1, 1, basically on the G of X, the point of inflection is on the left side of the maximum. But if I want to switch them around, I probably need to use reflection. Let's see what happens. Once you get this reflection, the problem with this one is you can see it's at minus 1, 1, but the point of inflection is at a 0, 0. So we're going to do some adjustment. For example, you can see the horizontal gap is 2. Therefore, you might want to dilate everything by a factor of 2. But you can see now, once the gap is 2, this becomes minus 2, 1. This is 0, 0. So we need to push that by 1 unit to the right. Then we could add a bracket x minus 1 and make it, let's say, minus 1, 1 and 1, 0. Okay, something along this line. So we can do dilation factor of 2. Dilation, reflection, translation. Okay, I know there are other possible answers, but the usual approach I would take is Dr. T. X is binomial 4p, so probability x greater than or equal to 3 is probability x equals to 3 plus probability x equals to 4. Now the first one is 4 choose 3 to the power 3, p to the power 3, 1 minus p to the power 1. The next one, you can write 4 choose 4, p to the power 4, and 1 minus p to the power 0. Then it's 4p to the power 3, 1 minus p, plus, this is 1, p to the power 4. So you get a 4p to the power 3 minus 4p to the power 4 plus p to the power 4. And that is 4p to the power 3 minus 3p to the power 4, which is exactly the same as g of p. Okay? So this is the first show that question. Make sure you show the correct algebra. Okay, question 2. You have these two functions. Just define them. These two numbers to be shown, but what I can do is I'll keep the a and the k first, okay, in the definition. Now, they intersect at these two graphs intersect at minus 12y and 2, 8, as shown below. So I can have two pairs of points. So g minus 12 equals to 1, and g of 2 equals to 8. So I have these two equations. Part A wants to get two simultaneous equations and solving them using algebra, okay? Now, This is just another form to write the first equation. Okay, so this is equation 1. This is equation 2. Now I want to use algebra to solve for K and A. This is actually a very standard unit 2 math method textbook question, I would say, because you can do 2 divided by 1, A times e to the power 2k divided by A times e to the power minus 12k equals to 8. Therefore, you can cancel the a's, and e to the power of 14k, that is equal to 8. Okay? And then we have e to the power 14k equals to 2 to the power 3. So you will have 14k equals to log e 2 to the power 3. That is 3 log e of 2. And therefore, k equals to 3 over 14 log e of 2. This is completing the first stage. And the next thing is you can find the a value, but you don't have to sub in k, for example. You can just use, let's say, well, we can call this equation 3, okay? From 3, we have e to the power 2k equals to a to the power 1 over 7, which is 2 to the power 3 over 7. This is 4. Sub 4 into, let's say, equation 2. Nah. Actually, I think I need to sub into another one. Let me think about this one. Yep, I can sub that into equation 1, see how we go. So we will have, let's say, a divided by e to the power 2k to the power 6 equals to 1. Gives you a divided by 2 to the power 3 over 7 raised to the power 6 equal to 1. And therefore, we have a equals to 2 to the power 3 times 6, that's 18, divided by 7. So we need to use another equation and get this a value. Okay? So that's pretty much how you get, let's say, the other a value algebraically. And then we can move on and have a look at the next question. Now, with the a and b values, a and k values actually, we can now define them. Yep, that's another form, which is equivalent to 2 to the power 18 divided by 7 whatsoever. What I'll do next is something like that, and then that equals to what is my a value times 2 to the power b times x comma b. Yep, that's how I get it. Definite integral. So this is my g of x. I can just define it now. Replace this one with the previous one. And then f of x, g of x. Okay, so now f minus g, analyze graph bounded area from here to here. Let's get a few more decimal places. Yep. expression for the derivative. Let's have a look. Oh, I don't want that. That's too complicated. Two different places, but this is not the maximum value. You have to sub this into h of x to get the maximum value itself. You have a half subtracting 6/7 multiplied by 2. Actually, bear with me. I can actually write the natural log 2 first, and then I write the exponential term, 2 to the power 3x divided by 14 plus 4/7. I believe there are other equivalent forms, depending on the CAS calculator, but this is definitely correct, I suppose. And the maximum value, okay. G inverse is the inverse of G. Find the points where the graph f G inverse of x intersect with the graph y equals to 2x minus 7. So if you try to solve x equals to g of y now for y, you get that expression. And then you can solve a pair of simultaneous equations, x, y. Control Enter. If you do Control Enter, you can force the calculator to get the exact answer because they are just integers. So basically, you can say G inverse of x equals to 2/3 natural log of 2. We can write, let's say, 7 natural log of x minus 7 natural log of 8 plus 3 natural log of 2. And y equals to 2x minus 7. You actually find these 2 points. 1 minus 12 and 8 comma 2. Or actually, you could recognize this is just y equals to f inverse of x, I suppose, because, yeah, if you solve x equals to f of y, you'll be able to get, let's say, 2 lots of x minus 7, and then the two inverses will have the intersection here and here, but you need to swap x and y, okay? Okay, f is an antiderivative of f that pass through 0, c. So basically, you could say integral f of x, comma x at a c. So you get that function. Now we can call it ff of x. Is that it is not possible to pass through both points. So if I have ff of minus 12 equals to 1, you can get a c value, and ff of 2, comma 8, we have another c value, but you can see these two equations are different. So first of all, write f of x equals to integral f of x, small f of x, x to the power 2 divided by 4 plus 7x plus c. And then capital F minus 12 equals to 1. You need to show the actual equation, I suppose. Get a first full c value. And then you get a f2 equals to 8. contradiction. A graph of y equals to capital F of x can be dilated by a factor of m from the x-axis, such that its image passes through both minus 12y and 2,8. So we say let capital G of x equals to, actually, don't use capital G. You can use capital F2x equals to m lots of x squared divided by 4 plus 7x plus c. Now we can say f of x is m times ff of x. And now we can solve, for example, I can get fff, and just solve them simultaneously. Yeah, I can get the values. Okay, so that's pretty much everything I need for this question, I suppose. Let's move on and then look at, let's say, the next question. Okay, mean and standard deviation, pretty chill. Let's have a look. F of t, 1 over 2, 1, 2, 1, 5, 0. T minus 29 times 59 minus t to the power 3. And mean value, just multiply by t from 29 to 59, t times f of t dt, 39. But I'm not writing E capital X, I'm writing E capital T, okay? So 29, 59, t times f of t dt equals to 39. If you wish, you can write, let's say, minutes and standard deviation. It's a square root of 29 to 59 t minus 39 squared times f of t dt. I'll put a bracket around t minus 39, and that's the answer. Okay, you might have worked out, let's say, et squared first, and then subtracting 39, which is also a valid working, I suppose. Let's have a look. Might do that, then minus that. Yeah, you can also get, let's say, a very similar answer. I'll put an or here. Moving on, the driver allows k minutes to travel to work each day. If the journey takes longer than k, the driver will be late. Whether the driver is late on a particular day is independent of whether they are late on any other day. So if k is 47, longer than 47, let's just do shift plus 47 up to 59, f of t dt. Yep, you get this value. And you can see this value is unrounded, okay? 272 divided by 3125. That can be written as a terminating decimal 0.08704. So you need to carry all digits if it's relevant to other parts. And the driver will be late on at least one day in 5 days working week. This is a binomial. Binomial. Let me just put my CAS calculator aside so I can get, let's say, n equals to 5, p equals to 0.08704. Okay. Probability at least one day, that is L greater than or equal to 1, but less than or equal to 5. We can just use binom CDF. Four decimal places. Okay, P hat is a proportion of days in a 5-day working week. So P hat equals to L divided by N, 5. Therefore, if I multiply everything by 5 here, this is probability 2 less than or equal to L less than or equal to 3. What are some places? One integer that such integer k such that a probability correct to one decimal place. Well, this probability is correct to one decimal place. What probability? The driver being late at least once in any 5-day working week. So for example, if you have, let's say, probability of L greater not equal to 1, that is 1 minus probability. Let's put an L2 here. L2 here equal to 0. In this case, L2 is a binomial distribution, n equals to 5. But P is unknown, okay? So what I'll do is 1 minus, let's say, none of the days being late. So it's 1 minus P to the power of 5. 5 choose 0, that's 1. P to the power of 0 is 1. And we want this one to be 0.2. We can solve that equation. Actually, it's just 1 minus p to the power of 5 equals to 0.8 for p. Notice this p is between 0 and 1, I suppose. So you should get that value. The next thing is this probability is the probability of the journey taking longer than k. And we need to relate this back to the previous integral. For example, k to 59 f of t dt equals to 0.0436475, something along this line. And notice this k value is larger than 29, but less than 59. So I'm going to solve. Let me just find an integration. This is a k equals to You might want to use this value or just all digits from the decimal form. And then you get 29 less than k less than 59. Yep, 49 something. And the question wants us to round it to an integer. So that is, the final answer, I suppose. Given traffic waiting time modeled by normal distribution. So R1, W1 is a normal distribution, 2.5, and standard deviation they use is 0.6. Now I would like to find the probability W1 less than 3.5. So we can use norm CDF minus infinity, 3.5, 2.5, 0.6. Two decimal places, 0.95. And find the value of sigma such that there is a 2% chance of wait time longer than 3.5. So if I'm using my cast, I'm going to use norm CDF longer than 3.5. That's 3.5 to infinity. Mean value is still 2.5. Sigma is unknown, and I want to make sure the result is 0.02 with sigma greater than 0. I'll put an S here. Longer than 3.5. That's an infinity. Equal to 0.02. Solve this equation for S, given S is larger than 0. Should be able to get, let's say, sigma equals to 0.4869, etc. So sigma is approximately 0.49. Yep, pretty chill. The driver passed through 3 traffic lights A, B, and C on their journey to work. I think that means the 3 lights are consecutive 3 lights in the order, okay? So red A, red B, red C. Well, you might want to do, let's say, start A, A dash, B, B dash, B, B dash, C, C dash, C, C dash, C, C dash, C, C dash. You have a 0.2, 0.8, 0.3, 0.7, 0.3, 0.7, and you have 0.1, 0.9, 0.1, 0.9, 0.1, 0.9, 0.1, 0.9. Okay, now, why is the number of traffic lights that are red? So if you look at a tree diagram here, basically, if you have, let's say, A, B, C, A, B, C, that's Y equals to 3. Totally, you have 3 of them. If you have A dash, B dash, C dash, for example, here, 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 you get, let's say, Y equals to 0. So these 2 cases are the easiest to figure out. So I'm going to use 0.2 times 0.3 times 0.1. So you should be able to get, let's say, 0.006 for Y equals to 3. And if you use, let's say, 0.8 times 0.7 times 0.9, 0.504. If you have 1 there, that means, okay, one of them, that means A, B, C dash, A dash, B dash, C. That is 0.8 times 0.7 times 0.1. And we might get, let's say, A dash B, C dash. We should be able to get a 0.8 times 0.3 times 0.9. And anything else? We could have, let's say, A, B dash, C dash. So we just see one red light, okay? One red light. Maybe I should highlight them using a different color. So let me just use the blue color. A to B dash, that is 0.2 times 0.7 times 0.9. Eventually, the sum of the three probabilities will be, let's say, the probability for y equals to 1, okay? Okay, that's 0.398. Suppose all the three numbers I obtained were correct. Then I'm going to use 1 minus that, minus that, minus that. 0.092, yep, should be fine. Let me just do a quick check. So you might get, let's say, A, B, C dash, A, B dash C, or A dash B C, something along this line, okay? So to tackle this question, the best approach is a tree diagram and using a tree diagram and listing all outcomes and organize them into a table. So that's pretty much question 3. Then we can move on. Function graphs question. We can have, let's say, f of x is assigned to sine x plus 1. Find the value. Okay. Exact values. Notice the domain restriction. Oh, this one should be 6. Bear with me. Yeah. Next part, let me have a look. There exist real numbers a and k in the interval 0 to 5 pi over 2 such that fx plus k equals to f of x for all x belongs to 0 to a. Find the value of k and the largest possible value of a. Well, if I draw a graph, say f of x from 0 less than or equal to x less than or equal to, let's say, a1. Let's try that. Create a slider. And I'm going to use, let's say, f of x plus, if I have, for example, 2 pi, actually, if I try, let's say, f1, well, how about I set this to pi over 2? Yeah, I think the intention is to use, let's say, 2 pi, but to be honest, I would say f of x belongs to 0 to a. It's better saying, let's say, 2 pi to 2 pi plus a. So actually, yeah, anyway, whatever. I'll just write. The domain doesn't quite match. This is my concern, but I believe the answer could be k equals to 2 pi. Say if you use k equals to minus 2 pi, it doesn't lie in the interval. Isn't that a contradiction? And a equals to the largest possible one should be half pi whatsoever, okay? And I think that's the intention. But see, that's the problem. If you consider the actual domain of that, I mean, if you use minus 2 pi, let's see what happens. Yep. So I think, yep, that was the intention, I suppose. So basically, that's something to do with the period and the translation. But anyway, consider the tangent to the graph y equals to f of x at point A. Okay, tangent line. So let's do menu for 9. F of x equals to 2 pi over 3. Yep, that's a tangent line. Newton's method. df of x is assigned to derivative of sine x plus 1 is just cosine x. So we can use x minus f of x, df of x, given x equals to 2 pi over 3. So get a first value. Then a second value. Should be able to get that. Let me just get, let's say, 2 pi plus 3 root 3 plus 2 divided by 6 minus x over 2. And then write down x2. Correct to 1 decimal place. On the axis in part D, well, sketch the tangent at the point x equals to x1. So x naught equals to 2 pi over 3. And this is x1 equals to 2 pi plus root 3 plus 2. Then the tangent at this point, you map this point back here and use a ruler to get, for example, a tangential point like this. I think you should draw the line like that, okay? Actually, let me just do some adjustment. Yep, should look like this. Okay, that is, at a point x1, f of x1, okay? And that's where you get x2, okay? Moving on. Consider the line y equals to t of x, which is a tangent to the graph at the point PFP. Show that, okay? First of all, f of x equals to sine of x plus 1. F dash of x equals to cosine of x. Equation of tangent at x equals to p. You have t of x equals to f dash of p times x minus p plus f of p. So that is a cosine p x minus p plus sine of p plus 1. And that's pretty much what you need to show, I suppose. That's an interesting show that question, but it's very standard procedural. And then I would like the y-intercept with the maximum and the minimum. So let me just define t of x to this expression here. We'll get a t naught and f max t naught. P between 0 and 5 pi over 2 as p equals to pi. and f minimum is at 2 pi. So at p equals to pi, maximum y-intercept equals to t naught given, actually, let me just find the question. Yep, this one. Yep, that's pretty much what you need. Okay, so determine the values of p for which the tangent has a unique x-intercept that is equal to the x-intercept of y equals to f of x. Give your answer corrected to decimal places. So we might get, let's say, this is 3 pi onto 0. That is the intercept. So if I draw a line from this x-intercept and get it to touch, let's say, the curve. Well, this is p, f of p. So we can use the strategy called equating gradient. The gradient we can form is f dash of p equals to f of p minus 0 divided by 3 pi onto minus p, I suppose. Now, the other way around, bear with me, should be p minus 3 pi onto. And we try to solve for the values p between 0 and half pi, 3 half pi's, okay? So we get a df of p, we defined the derivative before, equals to f of p minus 0, p minus 3 pi on 2, comma p, given that 0 less than p less than 5 pi over 2. And then we could get two values corrected to decimal places. We have p equals to 2.38126. So that's rounded to 2.38. And the other p-value would have been, let's say, 7.043511. And that's rounded to 7.04. So there are two p-values. Now, when I first attempted this question, I also used an approach like t of 3 pi on 2 equal to 0 for p. And I also used, let's say, this domain restriction. So I would get, let's say, this value, but the problem with this value is if you really get this p-value into the tangent line, eventually, technically speaking, this is y equals to 0. And because this is y equals to 0, this 1, 8, and 4 can be just negligible. It will intersect the x-axis infinite times rather than a unique x-intercept. So you would have to reject this value, I suppose. Of course, there are other methods like, get the x value and then equate to 3 pi over 2, something like that. And you should be able to get, let's say, these two p-values. Okay, show that a question. This is a polynomial. So G naught equals to F naught. Let me just write f of x here again. That's sine x plus 1. Obviously, G naught is d. F naught is sine 0 plus 1. So this leads to d equals to 1. And the G dash, all right, G dash of x here, that's 3x squared plus 2bx plus c. And f dash of x, from my previous working, it was cosine x. So g dash 0 equals to f dash of 0. That leads to, let's say, 0 plus c equals to cosine of 0. So c equals to 1. Basically, there are 2 marks for show that. Probably just try to show the specific work, like provide the derivative expressions for reference and show the clear substitution and evaluation. Okay. Because the answers are just given to you, c equals to 1, d equals to 1. You need to show the working for the show data questions as always. And then because c and d are 1s, you can just define, for example, g of x is assigned to a times x to the power 3 plus b times x squared plus x plus 1. And you can use, let's say, dg of x is assigned to derivative xg of x. Now, you have further conditions like f of 0 equals to g, actually, f of 2 pi equals to g of 2 pi. You get that equation. And you could also get, let's say, df of 2 pi equals to dg of 2 pi. And get the other equation. Just want to find, let's say, a and b value, and then you find the area bounded by the graph of y equals to f of x and g of x between 0 and 2 pi. So you get, let's say, from here, you get 8a pi to the power 3 plus 4b pi squared plus 2 pi plus 1. From here, you get, let's say, 12a pi squared plus 4b pi plus 1 equals to 1. Then you can just solve for, let's say, here and here, comma AB. You get A equals to 1 over 2 pi squared. B equals to minus 3 over 2 pi, I suppose. The next thing is, let's try g of x given these 2 values. And then go back. I'll delete this function. Delete this slider. And then I'll get a f of x. And f of x. And let's just do, let's say, g of x. Now, I can't use that. I need to copy that. Okay, so now I've got the 2 graphs here. Just copy this graph to show you a different color. Yep. And now from 0 to 2 pi, there are 2 equal regions. And you can see this cubic function will cut through, let's say, here. So the region is actually symmetrical. And then you can just use analyze graph bounded area to get, let's say, the desired area 1.5326, something on this line. So therefore, g of x for this question is x to the power 3 divided by 2 pi to the power 2 minus 3x squared divided by 2 pi plus x plus 1. And area equals to, I'll do 2 times 0 to pi f of x minus g of x dx. It will give you, let's say, 1.5326 rounded to 1.53. Okay, so I think that's the intention. And lastly, a equals to 0, c equals to 1, d equals to 1. So if I go back and look at my g of x, but now is just a equals to 0. We just get this function here. Let's redefine g of x as a quadratic. The next thing is I would like the derivative again. So once I define the G, I also need to redefine my derivative to refresh the previous one. And I've got G of R equals to F of R. So that's one equation. And dg of R equals to df of R. We can solve them simultaneously, I suppose. Well, if I try to solve, let's say, that, we can just cancel the 1 from both sides. And you also get, let's say, this equation, comma b, comma r. And the r value is actually between 0 and 5 pi over 2. So you can see, scroll from left to right. If you press enter, it doesn't give you any solution at all. But what you do notice is if you press control enter, at least you can get, let's say, minus 0.318 something and a 3.14159. 3.14159, blah, blah, blah. What if we look at a pi? See, this r must be pi. So you look from the decimal approximation and get an exact value. Now let's try, if we know r is pi, then we can actually grab, let's say, for example, this equation, r equals to pi, and then we get the b value, minus 1 over pi. Or we can get, let's say, the other equation, r equals to pi, and we try to solve for b, also minus 1 over pi, okay? So what I'll do is I'll just draw down, let's say, the equations. br squared plus r equals to sine of r. And 2br plus 1 equals to cosine of r. Solving gives, let's say, r value equals to pi. And the b value equals to minus 1 over pi. 所以我哋slide. So basically that is the last part of this exam paper. Hopefully you this paper you did well. You went well, and I'll be seeing you in the near future. Bye for now.